Welcome. In this video, we're going to look at one of the problems under beams, and in this case, we're just going to find the reaction force, which is this Fr, and then the distance from which the 500 newtons must be from the pivot in order for the beam to balance. So the question says, find the reaction force Fr in the diagram below and where the pivot should be in order for the beam to balance. So we're going to begin with the first question without even wasting much time. So for the first part, which is Fr, the reaction force. So this one, we want to find this one. We know that the summation of all the forces must be equal to 0 in order for the beam to balance. So from here, what we're going to do is, we know that summation of forces in Y must be equal to 0. So we have Fr, which is pointing up, so meaning it is a positive one. Then we have in the downward direction, we have, so 200, so minus 200 because it is pointing down. Then minus 100 newtons, and then minus 500 newtons. All these are pointing downwards. So this must be equal to 0 in order for us to obey the rule that to say the summation of forces must be equal to 0 in order for equilibrium to be reached. So from this one, Fr is equal to, when they cross the equal sign, they are all going to become positives. So we are going to have positive 200 newtons. 200 plus 100 plus 500, we're going to have 800 newtons. Okay, so this is the reaction force. So the summation of the downward forces and the summation and this force, which is the upward force, which is known as the reaction force, must be equal. So the reaction force is equal to 800 newtons. So now let us proceed with the second part, which is part B. So we have B. So the distance from which the 500 newtons must hang, this one it is. So the distance will be equal to L minus X. As we can see now, it is so much important that we come up with the L. Yes, when we come up with the L and the X, or rather, let us find one of the two and see what we're going to have. So we know from the principle of moments, the clockwise moments must be equal to the anti-clockwise moments. So we have for the clockwise moments, okay, so we have this one. So let's say Cm is equal to ACM. So we have 500, and you know, by the way, moment is actually the product of force times perpendicular distance from the line of action, or from the fulcrum, or from the pivot. So in this case, we have the pivot, which is here, and for 500 newtons, we have this one. So we have, so for this one, we have, let us call this F1, F2, F3. So F1, okay, or perhaps let me just go direct to avoid wasting time. So we have 500, so which is the force times the distance from the pivot, it is L minus X. So this must be equal to, so we have this 100 newtons, then distance from the pivot we have, so if this is X and this is the half, or this is the half L, or L over 2, and this is X, so we have the distance from this to this, it is this X minus L over 2, then plus, so this one for 200 newtons, we have 200 newtons as force, and then the distance from the pivot is equal to X, as we can see. So we have 200 newtons times x. So from this, we are going to have 500 times L, so 500 newtons. Okay, L. Then we have minus 500 newtons X, which is equal to 100 newtons X minus 100 L over 2 plus 200. So, okay, 200 newtons X. So since N is common throughout, so this will be cancelled. Okay, so we are going to have N. So from this we have 500L minus 500X is equal to 100X minus 2 into 100, 50L plus 200X. So from this we can collect the like terms. So we have 500 and this is 50. When it comes this side, we are going to have 500 plus 50. We are going to have 550L is equal to. So we have this one, which is 100x plus 200x plus, when this one comes this side, when it crosses the equal sign, it is going to be plus 500x. So this one we are going to have 550L is equal to 800x. So if we want to remain with x only, we can divide here by 800, also here by 800. So like this and this will cancel. And what we're going to have is x is equal to, so 800 into 550, we're going to have 0 0.6875 L. So this is what we are going to have. So from here, we know that the distance from which the 500 newtons must be hung, or must hang from the pivot in order, must be from the pivot in order for the beam to balance, is L minus x. So this one can also be rounded off to 0.69 L. So 0.6875. So this one, so our distance will be equal to L minus x. L minus 0.69 L, 0.31 L. So the distance, or rather 500, must be 0.31 L from the pivot, or 0.69 from 200 newtons. So it must be 0.31 from the pivot, and this one 200 must be 0.69 L from the pivot. And when it is like that, then the beam is going to balance.